Hi, today's lesson is about molecular formula. Let's start with a definition. A molecular formula is a formula that represents the actual ratio of atoms in a compound. It represents the actual ratio of atoms in a compound. The molecular formula is representing the actual ratio of atoms in a compound. It is based off the other type of formula we learned about last class, the empirical formula. A friendly reminder, EF stands for empirical formula, and we'll be abbreviating molecular formula with MF. Let's remind ourselves what the empirical formula is. The empirical formula is the simplest whole number ratio of atoms in a compound. And the example that we gave was hydrogen peroxide. And we gave this last class, where its formula is H2O2. As you look at this ratio of 2 to 2, we know that it can be reduced 1 to 1. So the simplest ratio here, gives us the formula HO. However, we know that this 2 to 2 ratio is the actual ratio, H2O2. The actual ratio is the molecular formula. The simplest ratio is the empirical formula. We wrote down just a moment ago that the molecular formula is based on the empirical formula, and it's based on it by mass. Here's what I mean. The relationship between the molecular formula and the empirical formula by mass. We know that the empirical formula is HO, 1-to-1 ratio. If I take the mass of one hydrogen atom and one oxygen atom, the molecular formula of this simplest ratio is 17.01 grams per mole. If I compare that to the actual ratio of H2O2, I have 2 hydrogens and 2 oxygens, for a total mass of 34.02 grams per mole. The actual ratio has a mass that's twice as much as the simplest ratio, because there are twice as many atoms. Let's read that main idea again. The actual ratio has a mass that's twice as much as the simplest ratio because there are twice as many atoms. That's what we mean that the molecular formula is based on the empirical formula by mass. So in conclusion, to find the molecular formula, we must compare the masses of the actual compound, which, remember, that would be the molecular formula, with the mass of the simplest ratio, that would be our empirical formula, to determine how many times more massive the actual compound is. This multiple is then applied to the formula. This multiple is then applied to the empirical formula. In other words, following our logic before, we knew that the actual compound of hydrogen peroxide had a mass of 34.02 grams per mole. And I'm comparing that to the simple compound, or the empirical formula's mass, which is 17.01 grams per mole. And we said that the actual compound is twice as massive as the simplest compound. So that must mean there are twice as many atoms in the actual compound compared to the simple compound. So if I know that the empirical formula is HO, and I need to have twice as many atoms, then the empirical formula, oopsie daisies, the molecular formula, sorry about that, the actual formula must have twice as many atoms, H2O2. So the molecular formula is the actual ratio of atoms in a compound, and it's based on the empirical formula by mass. Friendly reminder that the empirical formula is the simplest whole number ratio of atoms. For example, the compound hydrogen peroxide is the formula H2O2. That ratio of 2 hydrogen to 2 oxygen atoms can be simplified to a 1-to-1 ratio. So the simplest ratio is the formula HO. That's the empirical formula. The actual ratio of 2 to 2 is the molecular formula. So the relationship between the molecular formula and empirical formula by mass is determined by using the data from the periodic table for each of the atoms in the compound, adding them together, and then making a ratio. In other words, dividing the molecular formula by the empirical formula mass. In our example, the actual ratio has a mass that's twice as much as the simplest ratio because there are twice as many atoms, and we can see that in our formulas. But working backwards, if we didn't know what the formulas were, especially for the molecular formula, that brings us to the step-by-step process of how we're able to figure it out. To find the molecular formula, we must compare the masses of the actual compound with the mass of the simplest ratio to determine how many times more massive the actual compound is. This multiple is then applied to the empirical formula. So based upon how a problem would be showed to us either in the lab or on paper, we're starting with the simplest ratio, comparing that to the mass of the actual compound. In our example, the actual compound is twice as massive because there are twice as many atoms. Let's do some practice problems together. See you in class.